As we've seen, OpenAI's newly released generative model, Sora, is really good at making high-quality long videos. In this video, we're gonna focus more on the technical side, take a look at Sora's training details, and unfold what the real tech novelty is. Well, first, we know that AI researchers have explored video data generation through various methods before Sora. For example, RNNs or generative adversarial networks, autoregressive transformers, and diffusion models. These methods typically target specific visual categories or shorter or just are fixed sized. So why is Sora special and what's its secret sauce? Well, shortly after the news, OpenAI published a technical article. They mentioned that inspired by large language models that utilize text tokens or employ similar ideas of visual patches, blah blah blah. Well, the article has simplified the methodology a lot, too much just for simplicity. Well, using VIT for videos are not a new idea. For example, Google's Vivid in 2021 proposed a video classification model using transformers. Therefore, I asked NVIDIA's researcher about Sora's real novelty, and he reminds me of the academic context where researchers long debated the effectiveness of VITs and diffusion-based models. In recent years, VIT or visual transformers seems to become the model for mainstream visual architecture, except that U-Net still dominates the field of diffusion models. From DALL-E 2 to Stable Diffusion, U-Net is widely used in text-to-image models. In 2023, Google proposed MagVit, a video tokenizer designed to generate concise and expressive tokens for both videos and images using a common token vocabulary. The version 2 paper is even named Language Model Beats Diffusion. Tokenizer is the key to visual generation. The title tells the exact war between the two hotly debated methods. The proposed transformer-based model was integrated into Google's VideoPoet later, a large language model for zero-shot video generation. In that sense, yes, Sora proved that using a diffusion transformer or DIT model can achieve surprisingly good results. And what is DIT? DIT is a neural network structure that combines the benefits of both VIT and diffusion models. You can view a DIT as a VAE encoder and VIT and DDPM plus VAE decoder. So one of DIT's authors, Signing Shi, guesses and predicts about Sora in his tweet that Sora might have about 3 billion parameters deduced from the calculations on batch size, and that training the Sora model might not require as many GPUs as one would anticipate. He would expect very fast iteration going forward, so this might not be a super huge model as we thought. And he says Sora might also use Patch and Pack or NavVit from Google, another research work, to make DIT adaptable to variable resolutions or durations or aspect ratios. According to Sora, raw videos were compressed to a compact latent representation in both time and space. There's a decoder model later to revert the generated latent back to pixel space. Signing comments on that, saying, "Looks like it's just a VAE but trained on raw video data." And then let's take a look at what Sora did for text understanding. The Sora's team reviews that they trained a descriptive captioner model to generate captions for videos, first proposed in DALL-E 3's paper. This improves Sora's text understanding and overall video quality. They also leveraged GPT to transform short text prompts from users into detailed captions. Rewriting prompts is almost a standard practice for AI products today to bridge the gap between user instruction and model behavior. Another thing we care about is training data. So many people have guessed that Sora's training involves synthetic visual data from game engines. The extensive use of synthetic data may have taken an important role in the training. Sora is trained on videos at their native aspect ratios for better composition and framing, which is also something new. Last but not the least, takeaways. We all see that Sora moves the camera smoothly, keeps things looking the same even if they're far away. So the first technical takeaway is that diffusion model wins. Sora proved that the scaling law also holds for diffusion-based video generation methods, and using both diffusion models and the idea of tokenizations, they were able to achieve amazing generation results. And the second breakthrough is that Sora is able to create very long videos up to a minute, and that's very different from making a 5-second video from a technical perspective. Before Sora, researchers wondered if generating long, consistent videos would require methods tailored to specific categories or even with complex physics simulators. Sora's results tell us that this can be achieved with end-to-end general-purpose model training if done properly. What's even more exciting is that good video generation will also help many other fields to improve, such as 3D generation, autonomous driving, and robotics. And in the future, AI will eventually be able to simulate the physical world. And of course, researchers also have a lot of challenges. The next frontier lies in tackling the issue of error accumulation and ensuring sustained quality and consistency over time for generated videos. Let's look forward to Sora's launch so we can actually try it out, and hopefully we can conclude more from there. Well, thank you so much for watching.